Good morning, everyone, especially to our instructor, Mr. Anthony Gamali. Good morning, sir. I am Peter Mark Visto Oliveira, B. Scream 2, Section C, and as of today, I'm going to discuss the Chapter 3, Photographic Films and Papers. But before we proceed, what is forensic photography? So, forensic photography, sometimes referred to as police photography, forensic imaging, or crime scene photography. It is the art of producing an accurate reproduction of a crime scene or an accident using photography for the benefit of a court or to aid in an investigation. So let's proceed to the photographic films and papers. So the first one is black and white films. So a black and white film is basically made up of emulsion, gray or anti-halation backing, and a support base. So black and white films contains emulsion that when processed, it changes colors into various shades of gray. The earliest films of stock was autochromatic sensitive to blue and green, light wears and panchromatic which is sensitive to all light. Like I said earlier, black and white films is basically made up of emulsion. So emulsion is a photographic emulsion consists of crystals of light sensitive compounds or silver nitrate evenly distributed throughout plastic based material. So an emulsion is a type of colloid formed by combining two liquids that normally don't mix. In an emulsion, one liquid contains a dispersion of the other liquid. Common examples of emulsion include egg yolk, butter, and mayonnaise. The second one is gray or anti-halation backing. This layer is placed between the emulsion and the plastic base of a film to prevent whatever light that passes through the emulsion and reflected by the base back to the emulsion, which forms a halo. So gray or anti-halation backing is a layer found in many photographic films, almost all film intended for motion picture cameras. Usually, a coating on the back of the film base. Its purpose is to absorb light that passes through the emulsion, thus preventing any light from being reflected back through the emulsion from the rear surface of the base, or from anything behind the film such as the pressure plate of the camera. The third one is the base. Generally, film bases are made of plastic material. They serve as a support to the emulsion. So, the base is a transparent substrate which acts as a support medium for the photosensitive emulsion that lies atop it. Despite the numerous layers, the base generally accounts for the vast majority of the thickness of any given film stock. So let's proceed to the characteristics of B&W films. The characteristics of a B&W films are speed, sensitivity to light, spectral, wavelength or color, sensitivity, and granularity or graininess. Although films are universally manufactured in about the same way, there are controlled variations in procedure, choice, and proportion of chemical used in processing films of different characteristics. So the first one is the emulsion speed. But before we proceed, what is emulsion speed? Emulsion speed is the measure of the sensitivity of a photographic emulsion to white light where the exposed film has been developed by a standard processing regime. The different indicators of emulsion speed are as follows. Letter A, ESA or the American Standards Association rating. This is expressed in arithmetical value, letter B, DIN, or the Dutch Industry Normin Rating, which is expressed in logarithmic value, or the letter C, ISO, International Standards Organization Rating. This is expressed in the combined arithmetical and logarithmic values. In the market, ASA 100 commonly referred to as the plus X, the ASA 200 as the double AX, and the ASA 400 as a tri-X. The second one is spectral sensitivity. What is spectral sensitivity? Spectral sensitivity is the relative efficiency of detection of light or other signal as a function of the frequency or wavelength of the signal. In photography, films and sensors are often described in terms of their spectral sensitivity to supplement their characteristic covers that describe the responsibility. So spectral sensitivity have different classification of films as according to its spectral sensitivity. And those sensitivity are the blue sensitive film, sensitive film to ultraviolet rays and blue light only. That's the blue sensitive film. The second one is the orthochromatic film. This sensitive is also ultraviolet rays, blue and green light only. The third one is the panchromatic film. It's a sensitive to ultraviolet radiation to blue, green, and red light or all colors. The, the fourth one is infrared film. Sensitive to ultraviolet rays to blue, green, red light, and infrared rays. That's the different classification of the spectral sensitivity. So let's proceed to the third one, the granularity or graininess. So this refers to the size of the metallic silver grains that are formed after development of an exposed film. Generally, the sizes of metallic silver grains are dependent on the emulsion speed of the film and the type of developing solution that is used in processing. The rule is, the lower the emulsion speed rating of the film, the finer is the grain, and conversely, the higher the emulsion speed rating of the film, the bigger are the grains. Likewise, a film developer will produce a finer grain than a paper developer when used for film processing. So, granularity or graininess is the condition of existing in granules or grains, refers to the extent to which a material or system is composed of distinguishable pieces, the state or quality of being composed of many individual pieces or elements. So let's proceed to the color films. So color films is a multi-layer emulsion coated on the same support or base. The top emulsion is sensitive to blue light only, since green and red light passes through it without effect. The blue light alone makes the exposure. A yellow filter layer above the middle emulsion absorbs any unused blue light and prevents it from reaching the two lower emulsion layers. The yellow colors in the filter layer have no permanent effect on the appearance of the film because it is destroyed during processing. The middle emulsion is sensitive to green light but not to red light. Like all emulsions, the middle layer is also sensitive to blue light, but the blue light cannot reach it. The exposure in this layer is therefore made by green light alone. The bottom layer is sensitive to red light, but its sensitivity to green light is too low as to be negligible. Hence, the exposure in this layer is made by red light alone. These three emulsion layers are coated on a film base which has an anti-halation backing. So, my explanation in color films is it refers both to unexposed color photographic film in a format suitable for use in a motion picture camera and to finished motion picture film ready for use in a projector which bears images in color. Also, it contains light filters to filter out certain colors as the light passes through the films. Often there is a blue liquid filter between the blue and green sensitive layers and a yellow filter before the red sensitive layer. In this way, each layer is made sensitive to only a certain color of light. So let's proceed to the types of color films. As you can see at the picture, it is a diagram of an image formation of a color negative. So the first layer is the image formation in color negative film. Original subject represented symmetrically by color patches. The second one is the cross section of color negative film. Silver halide grains exposed in the camera have been developed to produce negative silver images. Simultaneously, dyes are formed with color couples in each emulsion layer. Third one is cross-section of color negative film after the silver grains have been bleached, residual color couplers. And the last one is the color negative. So let's proceed to the types of color films. The first one is the negative or non-reversal film. The suffix color is given to negative or non-reversal film. This film yields either a negative or a positive image depending on how it used. Examples are Kodacolor, Fujicolor, Agfacolor, etc. So, my explanation in negative or non-reversal film is that it produces an image that is the opposite of the original scene in color density. It can be printed on paper in a dark room to make a positive or scanned into a computer for editing and printing. So, number two, reversal film. The suffix chrome is applied to reversal material. This film, when processed, a positive image or transparency for projection viewing. Examples are Kodachrome, Ektachrome, Fujichrome, and Alphachrome, etc. So my explanation in the reversal film is in photography, a reversal film is a type of photographic film that produces a positive image on a transparent base. So let's proceed to letter C, the photographic papers black and white. So modern photographic papers are basically composed of a light sensitive coating emulsion on a paper base or support. The emulsion suspended on a gelatin is generally made of silver halide salts. To withstand the rigor of soaking in chemical solutions and water during processing and washing, as well as the variety of degree of humidity and temperature. The base is made of wood pulp. So my explanation in the photographic papers is photographic papers is a paper coated with a light sensitive chemical formula. So like photographic films, it is used for making photographic prints. The initial light exposure is carefully controlled to produce a grayscale image on a paper with appropriate contrast and gradation. So photographic papers has characteristics of a photographic paper. Or should I say there's a characteristic of a photographic paper? My bad. So the first one is emulsion speed. Emulsion speed consists of three characteristics. So the first one is chloride. Chloride has a low speed and is suited for contact printing. It means these insensitive paper are suitable for contact printing and yield warm tone images by development. The second one is bromide paper. Has a fast speed and is recommended for projection, printing, or enlarging. So this means papers with pure silver bromide emulsions are sensitive and produce neutral, black or cold, blue-black images tones. The third one is the chlorobromide paper. It's a multi-speed and could be used in both contact printing and enlarging. It means containing a blend of silver chloride and silver bromide salts. These emulsions produce paper sensitive enough to be used for enlarging. So let's proceed to the B, exposure and development latitude. Latitude is the degree or amount of which you can deviate from the ideal exposure or development without appreciable loss of print quality. So the first one is exposure latitude. Actually, I have a video which explains the exposure latitude. So let's proceed to the development of latitude. Papers that do not change appreciable in contrast and image tone with reasonable variation in development has good latitude. However, for best quality, the developing time should be as near as those prescribed by manufacturer. So that's the development latitude. So let's proceed to letter C. Contrast range or grade. What does it mean? So, in a black and white printing, it is often necessary to adjust the paper contrast so they can be yield and neutral scene result from negatives with density range that are either too high or too low. So some papers are available in several contrast range or grade, while others have built-in contrast control affected by the use of filter on the enlarging lens or on enlarger light source. So, in most photographic papers, the contrast range or grade are indicated by numbers number 0 to 5. So, number 1, numbers 0 and 1 are used on overexposed or low contrast negative. Number 2, numbers 2 are used on normal exposed or normal contrast negatives. Number 3, number 3 to 5 used in underexposed or high contrast negatives. So, that's the contrast range or grade. Let's proceed to letter D. Physical characteristics. So under this category, a photographic paper comes in different surfaces, base, thickness, or weight and color. Number 1. Surfaces of photographic papers vary in surface, texture, or degrees, glossy or sheen. They are the glossy and smooth, semi-matte or silk, and the matte or the rough surface. Number 2. Base, weight, or thickness. Under this category, we have the light weight, single weight, medium weight, and the double weight. Color may be cold. Number 3, color may be cold or white with a very slight blue cast, and a warm or cream where the white has light yellow-brown line. So that's the content of the letter D, physical characteristics. So let's proceed to D, photographic papers for color printing. So it is essentially similar to the film used in the camera, except that the emulsion layers are coated on a paper base and contains couplers which are colorless. Colored couplers are not used because the print would then be suitable for direct viewing. So, Printing a negative in complementary colors on a non-reversal print reverses both the tone, scale, and the color of the negative. Thus, the final result is a positive reproduction within the accuracy limits of the photographic processes of the tones and the colors of the original subject. So photographic papers, both color and black and white, are supplied in rolls or sheets in varying lengths or sizes. So that is all for the discussion of the chapter 3 photographic films and papers. Thank you.